Honorable dignitaries, guests, speakers, ladies and gentlemen, a very warm good morning to one and all. I feel extremely privileged to welcome you all to the National Conference on Use of Smart Contract in Public Procurement and Supply Chain. So, for the opening ceremony, I would like to call Shri Prabhat R. Acharya, Director, AJNIFM, to please come and join the panel. Now I request Professor R.K. Shyamsundar, Chief Guest and Keynote Speaker, to please join us. Dr. Madhuranjan Kumar, Head Procurement Research Center, please join us. Shri Sanjay Agarwal, Ministry of Finance. Shri Kavalpreet Singh, Ministry of Finance, so please join us. And our distinguished speakers, Dr. Amit Kumar Vishwakarma, Dr. Parvat Singh Anjana, Shri Deepak Lalan, and Dr. Sandeep Shukla. Now I request Shri Prabhat R. Acharya, Director, AJNIFM, to give the welcome address.
To you all distinguished guests, delegates, faculty members and staff from AJNIFM, members of the press. I welcome you all to this national conference on use of smart contract in public procurement and supply chain. It gives me great pleasure to welcome Professor R.K. Shyamsundar, Professor of Eminence of IIT Bombay, who is the chief guest of this conference and will deliver his keynote address shortly. We're looking forward to his address, which I'm sure will set the tone for this conference deliberations. Besides, I'd also like to welcome Dr. Manoj Tiwari, Director NITI, he's not come yet, I think, Dr. Sandeep Shukla, Professor of Computer Science, IIT Kanpur, Dr. Parvat Singh Anjana, Postdoctoral Department of Computer Science, IIT Hyderabad, Mrs. Swati Bhide, she's I think joining a little later, partner IBM, and Deepak Jalan, Associate Director Accenture, who will deliver the talks during the course of this conference. I also welcome on board my colleagues, Mr. Sanjay Agarwal and Kunpan Singh from the Public Procurement Division of Ministry of Finance. Now, as most of you would be new to this name called AJNIFM, I thought I must tell you briefly what exactly is this institute about before you proceed with the conference deliberations. Now, Arun Jaitley National Institute of Financial Management is an autonomous training institution of the Department of Expenditure, Ministry of Finance, Government of India. It has a unique mandate of meeting the capacity building requirements of the departments of central and state governments, including defense services, autonomous bodies, PSUs, through its various short-term executive and management development programs. Besides, it also offers degrees and diploma programs, which are a year to 2 years programs in the areas of financial management and financial markets. Besides, it is mandated to carry out various research programs and also various publications. The research programs are generally executed through memorandum of agreements or memorandum of understanding signed with client departments and are mostly action-based research as per the terms of reference given to us. These research outputs help the departments to take policy decisions. Today's conference emanates from one such research program that is being carried out by Agena FM through a memorandum of agreement signed with the Department of Expenditure, which has set up a procurement research center or a cell in Agena FM in January 22. I'd like to inform you that to this august audience that the Public Procurement Division of the Department of Expenditure is responsible for all policy matters relating to or pertaining to public procurement. Agena FM is a nodal center for public procurement capacity building programs on behalf of this Public Procurement Division of Department of Expenditure. Last year, Agena FM had organized an international conference on data analytics in public procurement and supply chain on 10th and 11th of June 22. And now, it's a matter of privilege for Agena FM that on behalf of the PPD of DOE, we are having the opportunity to disseminate initial fledgling steps that are being taken by Agena FM in this futuristic domain of smart contract to this August gathering of more than 120 delegates drawn from about 63 government departments, 29 PSUs, 25 academic institutions, and around 5 private sector organizations. I'm sure they will be joining us during the course of the day. So this gathering will capture by and large the entire geography of India, extending from Punjab to Meghalaya to Tamil Nadu. As some of you may be aware, smart contract is a self-executable computer program that automatically enforces the terms of an agreement between 2 or more parties. In the context of procurement and supply chain, a smart contract can automate many of the steps involved in procurement process, from initiating a purchase order to verifying the delivery of goods and services and making payments. Smart contracts can be used to ensure that all parties involved in the procurement transactions comply with the agreed terms and conditions, thereby reducing the risks of fraud and error in procurement process. Smart contracts can also help in improving efficiency in procurement by reducing the needs for intermediaries and manual processes. By automating many of the steps involved in procurement, smart contracts may also help to reduce the costs and improve the speed and accuracy of procurement transactions. Most importantly, smart contract facilitates transparency, traceability, and autonomy, both in design of contract as well as contract management. I understand that the autonomy and security in smart contract comes from the cryptographically secure capturing of contractually significant events. I understand that smart contracting emerged in the early 90s, but many issues and challenges remained. However, the emergence of blockchain technology has helped providing a platform on which smart contract could be built and delivered. Through challenges, those challenges still remain, particularly the initial costs, interoperability, legal issues, capacity constraints, etc. There are many potential benefits too. Smart contract is still an amorphous concept when it comes to public procurement. Therefore, this conference aims to enlighten the stakeholders and academicians interested in smart contract, public procurement professionals from government and PSUs, and private sector professionals interested in learning about smart contract in public procurement. The speakers who have kindly agreed to address this conference are the leading lights in the domain of smart contract in India. The Procurement Research Center of Agena FM is also attempting to develop the first ever smart contract for a Ministry of Government of India, and Dr. Amit Vaishpik-Shwakarma, our consultant on smart contract, will briefly discuss on that. We look forward to your active participation in this conference. And I think I will now leave it up to Professor Shyamsundar, Professor Eminence of IIT Bombay, to enlighten us with his inaugural address. Before that, I think the MC will introduce him. Thank you so much. Have a very good deliberations, please. All the best. Thanks.
Thank you so much, sir. So with this auspicious start, now I am going to start the inaugural session. So I will request all the dignitaries to please take the front row. Thank you so much. The inaugural address will be given by Professor R.K. Shyamsundar. Professor Shyamsundar is currently J.C. Bose National Fellow and a Distinguished Professor at the Department of Computer Science, IIT Bombay. Prior to this, he was a professor in Computer Science Department at Tata Institute of Fundamental Research. He is also an adjunct professor at National Institute of Industrial Engineering, Mumbai, a life fellow of Institute of Electrical and Electronic Engineers, and a distinguished alumnus of the Indian Institute of Science. He heads the Information Security Research and Development Center of the Department of Electronics and Information Technology of Government of India. He was awarded the 2014 SN Mitra Award for Excellence in Research by the Indian National Academy of Engineering. He has 8 patents, 8 books, and guided more than 40 PhD students. He has also been honored with a fellowship from British Blockchain Association. So I request Professor R.K. Shyamsundar to please come onto the stage and deliver his lecture. So please.
Thank you. I think it's a pleasure to be here. First, let me thank Shri Madhuranjan Kumar for giving me the opportunity to address a faculty who are really interested in trying to see how contracts can be automated, or when you call a contract a smart contract, and when what would be the advantages or the disadvantages. And also I asked Shri Madhuranjan, what is the way, what is the audience? So he said there are lots of things, but you should speak as if it is a 101 course, and then I'm going to be addressing people have questions or comments. You are free to stop me at any point. I think I will be giving for the next 1 hour and then 15 minutes as a question answer. So thank you again, all the distinguished speakers, and also Dr. Acharya, who is the director of the institute, who has also come to see how the conference and then what will be the impact. Thank you. So this is I think, you know, this there of organization of my, there is. Is there a way? No, I think either. Thank you. So it's the rough organization. So just to highlight the point, what is a contract and why do they go to smart contracts, and why do we call smart? Where is the smartness there? Because we are always confused with the smartness whenever we talk about something, including AI. So, you know, AI of the Esther era, starting from Alan Turing and to what we call AI is totally different in some sense. So smart contract definitions, I will just take a brief look and then give a brief on blockchain foundations, because that also will give you what are the issues for executing the smart contracts, and what is the scope of applications. And also I will try to highlight traditional contracts versus smart contracts, and what would be the issues or the conflict areas of smart contracts and the traditional contract. So, so this is something I thought it was good to see, because the smart contract idea was the innovation is all pervasive today. For example, even the policymakers foster innovation. Nowadays, the word innovation comes more from the policymakers rather than from the scientists or academic people. Like the European Commission declared we need to do much better at turning our research into new and better services and products if we are to remain competitive in the global marketplace and improve the quality of life in Europe. That's what, with respect to Europe, and similar thing exists, like our Prime Minister goes on telling how innovation is important, kind of a thing. So innovation is seen as an economic driver and has led to political efforts to remove the rules and regulations that limit or restrain its development. The economic perspective of the role of innovation is economic growth is also embraced at a firm level. So now if you look at the original concept of innovation, it concerned novelties like imitation, invention, creative imagination, and social change. But now the current use is directed mainly at the technological innovation. And so the complexity of technological innovation poses a great challenge to the law. Disruption of the law is a phenomenon through which law becomes decrepit in the face of modernity. So now here, a blockchain and its impact on economy, if you look, blockchain technically has sparked a revolution in several sectors of the economy, just as the internet did in an early time. However, the blockchain was developed, you should note, as the result of a venture that was driven by libertarian ideas, eliminating the need for intermediaries. That is the basic important things, such as central banks, courts, and other governmental bodies. Central to this revolution is the idea of contracting without the state. That is a major thing, and that's how people think transparency will come into the picture. By entering smart contracts based on blockchain technology. Of course, escape from the law is a mere illusion, as law will continue to play a vital role in private transactions. So now let us look at contracts. Contracting the world, now in an exciting period of innovation and research, contract law has proved to be sufficiently flexible and malleable in adapting to new technologies and transaction types. Of course, a top-down regulatory framework will always be needed, otherwise things won't work. Understanding and collaboration among scholars, practitioners from different jurisdictions, as well as among the legal and technical communities, approaching the intersection of law and technology. So now let us look at the origin of the smart contracts. It is technically, it was Nick Szabo in 1996. In fact, I think somebody asked him, are you Satoshi Nakamoto? Because he's such a very great innovator who has done a wonderful work. If you want to name two persons, one is Nick Szabo, another one is the David Shum. Because these are two persons without which I think many of these things would not have existed, kind of a thing or the other. And so now here, if you look at what he defined the smart contract, you see that it is 1996. Blockchain had not really come into the picture, or the Bitcoin had not. I should say Bitcoin because blockchain is a byproduct of the Bitcoin kind of a thing or the other. And he said, the goal is to combine protocols with user interfaces to formalize and secure relationships over computer networks. Objectives and principles for the design of these systems, derived from legal principles, economic theory, and theories of reliable and secure protocols. See, you see how much technology that exists when you want to understand what is the notion of a smart contract. the blockchain is one such thing which gets embedded rather than that is not the only technology that is there. There are similarities between smart contracts and the traditional business procedures based on written contracts, controls, and static forms. So smart contracts, how did they arrive at it? Through the use of cryptographic and other security mechanisms, we can secure several algorithmically specifiable relationships from breach by principles. That means that using cryptography, just like what we say it is immutability or whatever it is, that can be done through the cryptography. From eavesdropping or malicious interferences by third parties, up to considerations of time, user interface, and completeness of the algorithmic specification. So now, a classic example is a vending machine. A classic reactive systems, people who are in computer science, they know reactive and proactive systems. Reactive systems don't interact unless you hit it, it won't respond, whereas in a proactive, you go on doing it in a proactive fashion. For example, in this case, machine takes in coins via a simple mechanism, dispenses change or the product according to a displayed price, and a vending machine is technically a contract with the bearer. Anybody with coins can participate in an exchange with the vendor. The lockbox and other security mechanism protect the stored coins and contents from attackers sufficiently to allow profitable deployments of vending machines in a wide varieties of areas. This is a primitive ancestor of a smart contract. So there are other forerunners, as you can see, a point of scale, that is the terminals and the electronic data interchange and so on and so forth. SWIFT also is one of such things you can see. And these implement commercial security models, but too often with little heed paid to the contractual needs and obligations of the parties. And this is where the things comes into the picture. The smart contracts, though they go beyond vending machine in proposing to embed contracts in all sorts of property that is valuable and controlled by digital means. Smart contracts reference that property in a dynamic, often proactively enforced form, and provide much better observation and verification where proactive measures must fall short. See, that is the beauty of this. This is a classic example, a hypothetical digital security system for automobiles. Smart contract design strategy is successively refine the security protocols to more fully embed in a property of the contractual terms which deal with it. These protocols would give control of the cryptographic keys for operating the property to the person who rightfully owns that property based on the terms of the contract. And this is where you see how that happens. So now, what is the thing? Car can be rendered inoperable unless proper challenge response protocol is completed with its rightful owner preventing theft. And so if the car is being used to secure credit, strong security implemented in this traditional way would create a headache for the creditor. Repo man would no longer be able to confiscate a deadbeat's car. To overcome this, one can create a smart lien protocol like this. If the owner fails to make payments or installments, the smart contract invokes the lien protocol which returns control of the car keys to the bank. So protocol might be much cheaper and more effective than a repo man. And further reification would provably remove the lien when the loan has also been paid off. You don't have to go, as we have seen in many of the licensing or renewal licenses. As well as there are operational exceptions. As you can see, if the car is going at some 100 kilometers on a highway and it cannot stop, and now it is just the same strategy like what we have in our push-button cars. No, you can say the key is thrown away. Will it stop somewhere? No. Till you stop, it will continue to go. And when you stop, it won't start. So that is the way in which this has to be done in an automatic way. And this gives you a picture of how a smart contract is there, kind of a thing or the other. So smart contracts Of course, no one will say what are the definitions. For example, even artificial intelligence people ask for a definition. So now, like Alan Turing, for whom we celebrated the century in 2012, somebody asked him, because he's the originator of the AI kind of a thing, he said, the day I'm going to define, it gets dead. So, so there is no single and universal definition of smart contracts, as has been observed. A search of the term smart contract uncovers a myriad of definitions. A consensus definition for smart contracts is yet to be reached, and a generally accepted definition of smart contracts does not exist. So I will take one definition and proceed with the underlying blockchain technology and come back to the other definitions later. Smart contracts and blockchains. Smart contracts are literally computer code that is placed on a blockchain, an open distributed ledger that runs on the computers of thousands of users, which has no central authority. So smart refers to the self-performing, self-enforcing quality of the smart contract, which I think I conveyed something through the automobile loans kind of a thing or the other. So these contracts are immutable, meaning that the code by default cannot be changed, that ensuring performance. However, for programmers, immutability presents a special challenge. Of course, you know, software bugs always continue to be there. Code contains bugs, coding errors, and code that cannot be altered needs to be written carefully, and these are all aspects you can look from different perspectives. So now let me just give a blockchain a gentle introduction. So now, as you can see here, here's the person wants to perform unless broadcaster willingness to transfer some money to Bob. And now the nodes check whether this thing can indeed be performed, and then if it is going to be performed, then it goes to the next one. And now here is a point there you have to understand is that now Alice wants to give 2 to Bob and somebody else give 1 to give, and so these are all the transactions that have been collected, and now this has to be validated. That means that all the way from the genesis, is it possible this transaction will go through? I can account for each and every penny that is being there kind of a thing or the other, and now once that one is true, and then that becomes a block. And that block has to be added to the sequence of transactions or sequence of blocks of transactions that has happened to that, and then that is where this becomes the chain. So technically, this is a very gentle way to do that. You give it to all the stakeholders, and then at some point or the other, each one wants to add a set of valid transactions, and that valid transactions are going to be, somebody is going to be chosen in some manner or the other to say what is the block that has to be added to the chain, and then who would do that, you will come to that at a later point or the other, and now when that block, he is the winner, he will get it validated by all the stakeholders. So technically, it's a consensus, it's not even a majority, everyone says that this one is correct or here. So let us see what is the thing I can convey. One of them, let us say, Alice is Bob's grandmother and is passionate about technology. So she decides to code her last will in a smart contract. So in her will, she specifies that all her money that is in the form of cryptocurrency should be transferred to Bob's wallet address when she passes away. So additionally, she can specify further conditions, for instance, that the money can be transferred only after Bob's graduation. So now here comes the thing or the other, where one would say whether when do you certify the death, when the graduation certificate is there, when the money has to be transferred, and where is the address to which the cryptocurrency has to be transferred. So this is technically a simple code that exists and that can run on the blockchain and then realize what that will is. There is no notion of a court or anything like that, and so this has to be executed. This is all completely automatic kind of a thing or the other. So now you have to observe something. This is also an important aspect. because blockchain is one in the cyberspace. And now you also have to relate it to the real world. And that is where you have to see where the things comes into the picture. And there also you will come to know what is the notion of a trust, etc., coming into the picture directly or indirectly. The smart contracts are essentially evolved wallet accounts characterized by a unique address and by a balance. That is the way the things are, because that is where the cryptocurrency is stored. It can store the state of some variables and their own code, which is on the blockchain. Alice could shape her smart contract to store 3 variables. For example, owner alive. That is, initially it is set to true because it has been, she has written, and so she is alive. And so that's how the timestamp also makes a good need, and why that one is needed. And benefactor address to store the address of Bob's wallet, that is the beneficiary. And the beneficiary, whether he is graduated, initially set to false because he is still studying in the college. And smart contract code would then contain some functions which would be used to modify the state. And so now here, if you look at the observations, the smart contract are not able to retrieve data from the real world. It relies on external services called the oracles. So that is a key point. Like when one is dead, when one graduates, these are all things that have to be obtained from the external world to the cyberspace kind of thing. Oracles take information from the real world and inject it into the blockchain. And so, in fact, it is here the IoT has played a very vital role, and that's how now you would say IoT plus blockchain and many other things are there, and how it would relate even in the 5G world. Hence, Alice could decide on 2 oracles. The first one would periodically inspect death records, and if it finds a record related to Alice's death, it would trigger the set death function. And then the second one would monitor graduation records, would eventually trigger the set graduation function if Bob graduates. So now here, observations continuing. There are what kind of oracles could be there. One is the software and hardware, and another one is the so-called inbound and outbound. The software generally extract information from the web sources. And now the hardware oracles are used to gather data from the physical world through sensors, and that is where the IoT plays the vital role. And so inbound oracles are employed to insert information in the blockchain, whereas outbound oracles are used to reflect in the real world a blockchain state. So for example, oracles used by Alice are inbound software oracles, whereas in other contexts, outbound hardware oracles could be used to let an intelligent locker automatically unlock as soon as a person pays for it by issuing a transaction on the blockchain. So that's how the integration of the payment system also comes into the picture. Note that the role of oracles is very, very important, as their incorrect behavior could have negative consequences. And so now here, if you look, I will go in a quick manner the blockchain in some detail. One of the reasons is that, people will ask what happens post-quantum. All this, if you do, all these are going to be dead, or what is the thing or the other. And so that's how it will give an idea, and what is the impact if the post-quantum comes into the picture, cryptography and all these aspects. So this gives a general notion of a ledger. I will not spend much time on this kind of a thing. For example, if you say there is a CD library, one can have a ledger. That means you can say what are all the CDs she has, and what are the CDs B has, and what are the CDs C has, and what has been borrowed from B to A or B to C, etc. And these forms the ledger. What is the reason I am using the word ledger? In a classic thing, you also call the general technology as the distributed ledger technology. Because in all the banks, each one has its own ledger, and that's how you have to come up with whether there is one unique ledger that has been accepted by every stakeholder or not. And if there is a discrepancy, then it becomes a problem or the other kind of a thing. So in a sense, this gives you a ledger. And so now, to give a brief about Bitcoin, because blockchain is a byproduct of the Bitcoin. So now the question that has happened is, it is nothing but identities and signatures. which has public and private key pair, and ledger is a balance of each identity which is saved on the blockchain. So transactions, you can say, I can move bitcoins from one identity to another and serialize the transactions. Why do you need a serialize the transaction? Suppose I have an amount A and I want to send an amount A by 3, and then another one I want to send it again 3 upon 4, and now you see only one of the transactions can go through. So now I have to serialize the transaction so that I can say what is the valid transaction and what is the thing that cannot go as of now, it has to be submitted again, kind of a thing. So serialization is a very important aspect that comes into the picture, and that's also important from a fairness perspective. Because it could be the case at some point or the other, everyone is trying to see that one transaction will not go through. It is something like a conspiracy can become into the picture, and that is where the fairness comes into the picture. Serialization is a very important aspect or the other, and these are all the transactions, they are all logged. There is nothing deletion coming into the picture. Log is persistent, and it is immutable and tamper-free. That because of the hash power or the cryptographic power. And this is a classic ledger, what you would see in a classic bank kind of a thing or the other. And so now here, this is the digital signature, and you can sign this document from your secret key, and you have a signature, and this can be verified from a public key, and then you would see PK is made public and used to verify documents which are signed by SK. SK is private, it is a secret key. And so like that, you would see in the digital signatures and this one, a Bitcoin is a chain of digital signatures. So like you see in the Genesis, I have something like whatever I have encoded as a Bitcoin, and that has been signed by PK Bob, because here it is something Alice wants to move a Bitcoin to Bob. So now here I want to send it to Bob, I use his public key, so only he can decrypt it using his secret key. So then it becomes a signature of Alice and Bob, and so now here from one signature it has become two signatures. So similarly here, if now Bob wants to move his coins to Diana, that becomes another signature, and that gets added. And so you go on enveloping this Bitcoin by various envelopes of the signatures or the other. So that also gives you what is the order in which it has been taken, kind of a thing or the other. So now the question is that how does this function look like? So this one is addressed by this, which says that Bitcoin uses the SHA-256, and here if you look at the 256, it gives a finite number of string for whatever you are going to give it, and so this is the one. Now if I take 256 bit, which is this one, for example, if this function, if I take the string ABC, which is C is a lowercase, and here if you take the capital C, these two you can see, you cannot see what is the similarity here, and that's how this is the randomization and all this comes into the picture, and so this is the way the function is going to be represented. And so now the question is that that one is fine, but the question is that is it going to avoid double spending? To use the word double spending, suppose I have the physical cash, let us say 1,000 rupees. I can give it to Madhuranjan, so let us say, and now I will not have 1,000 rupees, only Madhuranjan has 1,000 rupees. And now, if in the digital world copying is free, I have still the copy. The same thing I can give it to Mr. Acharya. So then it becomes that I have used the same money 2 times. Now the question is that how do you avoid double spending is the main question that has to be addressed, and that is what the thing that was addressed by the Bitcoin by Satoshi Nakamoto. So that is the one. So now if you say the double spending the same digital cash asset more than once, impossible to do it in physical cash because it's a mutual exclusion. So now you may ask some people who are quantum theorists whether mutual exclusion is guaranteed in the quantum computing. That I will not answer now. We will only take it at a discussion level or the other. So that's a totally a different question altogether. But in the physical world, it is mutually exclusive. In the digital world, it is coming, everything is available, and so you have to see how you can avoid it, kind of a thing or the other. And so now here, the double spending in the classic sense, what would you do in the classic our banking system? Now if I have this 50 bitcoins, and if I want to transfer, I will go to the bank and say you transfer it to this, like a trusted third party. But I don't want the trusted third party, and that is the question, how do you overcome the trusted third party? And that is the double spending prevention has to be done in a completely decentralized manner. A network of nodes maintains a ledger, work to agree on the transaction order, and now the ledger, I have given you an indication how it looks like, and that is the reason. So now here, you see the genesis, these are all the transactions that were collected, and these are all valid, and you have the hash, and the next block when it is added, you have the hash, and you have the hash, and now if you have the nth one, you have the hash of all these things or the other. Blocks are chained to each other through pointers, hence it is called a blockchain. And then Satoshi used this while writing his software in his code, rather than trying to say this is exactly the blockchain kind of a thing or the other. So now the ledger is, blocks are connected through the hash pointers. Each block contains the hash of the previous block. This hash gives each block its location on the blockchain. Tampering with the content of any block can easily be detected or the other. So this is not good enough to be, this one we will see why. Blocks are connected through the hash pointers. Each block contains the hash of the previous block. The hash gives each block its location in the blockchain. Tampering the content of any block can easily be detected, and now replacing a consistent blockchain with another tampered code should be made very hard. That means, so for example here, if you look at it, if you change these transactions, now this hash will not match, and this becomes an inconsistent chain. Now if you want to make it, I have to go on changing all these hashes along with this transaction coming into the picture. This task is very costly, and so this becomes, that's how this you will say that it is immutable, because the amount of effort you have to put is enormously a large kind of a thing or the other. And so making progress, the ledger is fully replicated to all the network nodes. There is nothing that is hidden. And then network nodes group new transactions like 1 megabit, that is blocks are fixed size. Network nodes validate new transactions to make sure that transactions on the new block do not conflict with each other. So the whole block is non-conflicting set of transactions or the other, and transactions on the new block do not conflict with the previous blocks. One is in the same, this one, and also it should not conflict with the other one kind of a thing. For example, if you introduce many conditional transactions, there may not be possible to have it no conflict in the same zone, so it becomes an issue. So network nodes need to agree on the next block to be added to the blockchain, and that is where you get into the consensus problem. That means everyone has to agree, now you are the winner, and so you can add it, because anyone would have taken a block and trying to do that. So that's how it's a consensus. So Nakamoto's consensus was race to solve a puzzle. This puzzle is computationally expensive. Once a network node finds a solution, it adds its block of transactions to the blockchain. It multicasts the solution to other network nodes. Other network nodes accept and verify the solution. This is the way you are going to sign the transaction. So this is a thing, as you can see, each block holds a block header and a body with a list of transactional recently added. And now here you have this one, and you can see there is something that you have to add as something as a nonce, and then what is the thing you can add it as a puzzle. So what is the puzzle? So now that is where you say that the block version is everything is clear. A nonce is used in the creation and verification of a block. N bits a target a threshold of a valid block hash, because it puts a challenge. If something is put on this, what is the challenge that has to be done? And that is how you would say that the first 4 zeros, first 5 zeros, or first 6 zeros should be there kind of a thing, and the parent block hash it has on the previous block or the other. So that's how the timestamp, etc. kind of a thing. Let us not need it, we know that. And now here, if you look at it, the puzzle is proof of work. So now here, as you have seen, the previous hash and you have the nonce and then doing that. The challenge I showed can be done by changing the nonce. And this is a sequential action. It cannot be done in parallel. That's how it becomes exponentially possible. That means you have to go on trying, increment it, and then see whether I get the hash with the 4 leading zeros, etc., kind of a thing. This cannot be parallelized. And that is the thing. They implement the POW by incrementing a nonce in the block until a value is found that gives the block hash the required number of 0 bits. This is a very costly operation, and it is sequential. It's a purely, highly sequential, inherently sequential, and that's how the CPU effort, it satisfies the block cannot be changed without redoing the work, or changed after it. The work to change the block would include redoing the blocks after it. And so now here it solves that problem or the other. And so now here comes the picture of what would be the, is it possible 2 persons can actually, let us see. Yeah. Okay. So it is possible at some point 2 stakeholders win over. So now it becomes a fork. This is a blockchain for which one person has added this and another person has added this, and this indicates a possible double spending. This is possible. So now here, and that is how the double spending is not completely done away by just doing the sequential ordering. And now if you look at this point, and now suppose this guy succeeds in adding another block, and now that gets added, and now here, and this becomes defunct. That means these transactions have to be resubmitted again, and now this becomes the longest chain for which it has to be added kind of a thing or the other. And so now here you can see, now why do you say that it is valid? From here, if you go to all the way to Genesis, even from here to here it is valid, from here to here it is valid, but now the question is these two, they don't meet, and now, and that is where it is something like a double spending. So now if you add this and it is single chain, now the double spending has been avoided kind of a thing or the other. And so now that is where it comes into the picture. You have something like how the other attacks are possible and so on and so forth. I will not go into those aspects or the other for want of time. And you can also have, this is one other point that what I want to mention, to some extent when a stakeholder finds a block, he need not have to announce I have found a block. And so now he can keep it, and then he would have created a hash, and he would create another one, and so he will add, because it has to be the longest chain, and now because this is the one which is valid here, and this gets added, and this gets defunct, and now that you see that all the work, whatever he had done, becomes completely defunct kind of a thing. So limitations, you have a high transaction confirmation latency, probabilistic consistency guarantees, very low TPS, like MasterCard has a huge number, whereas here it is the average of 3 to 7. And I think my colleague who will show the scale up, how they have scaled up, etc., that's a different thing. I will not talk there. And so new block is added every 10 minutes or the other. So in the blockchain challenges, you have one is the architectures have to meet the enterprise requirements. So now here, if you look at it, can I just adopt the blockchain as it is for all the enterprise requirements? What are the enterprise requirements? I need a settlement finality. I need performance. I need speed and scalability. Now if you see the settlement finality in the context of blockchain, in 1 hour, perhaps it is probabilistically, you can say it has reached a finality. And so now here, if you are not able to settle finality, enterprise people won't like to have it at all because it is something I cannot give an answer. So now here, similarly, governance, privacy and confidentiality, of course, compliance and safeguards kind of a thing are there. So now here, if you look at it, you have the blockchains are trustless, always require some kind of trust. And they are 100% secure are not automatically more secure than other systems. I will not go into there because one of the main reasons is that in a blockchain, if you enter it, then you are a king. Whereas in the classic thing, it is almost like an onion layer. If you are in first layer, the other persons can sense something is happening and they can stop. Second layer, third layer, fourth layer. Whereas here, once you get into that, you have serious problems and then you have to do that. And of course, like the classic computer science, garbage in is garbage out. If you don't give a proper input, you will always get a garbage kind of a thing or the other. Blockchain architectures, that's how you have something like a permissioned and permissionless. Bitcoin is a permissionless, and now the main operations are read, write, and commit. And based upon this, you have various classes of architectures. One is called the permissionless, which is read is open to anyone, write is to anyone, and commit is to anyone. Whereas in the public, which is permissioned, write is only authorized participants, and consortium, it's again restricted to the consortium people, and whereas private, everything becomes this one. So unless you have permission, governance and grievance redressal becomes extremely difficult, and that is where the enterprise requirements have to be met. You go for this kind of architecture to see whether this one is going to be satisfied at all or not. So like that, this the classic architecture, which you say distributed databases, distributed ledgers. What is the difference? They can have adversarial model. That means, and you have the blockchain, you have a data structure, and then the whole thing comes into the picture where I have the immutability and all that comes into the picture, and then you have the permissioned blockchain where only permissions are there, whereas blockchain is a permissionless kind of a thing. So you, within this you can have varieties of things, and then you can simply ask a question as to whether you need a blockchain or a database would essentially do. You can just say, do you need to share the data? If you don't have to share the data, you don't need a blockchain. You can just do away with just a simple database. And or these, there are multiple writers, and if there are no multiple writers, you don't have to worry about that at all. And now then you can ask, when the multiple writers are trusted, if they are trusted again, you don't have to worry about it. And then similarly like that, you can go on saying under what conditions you can go for a blockchain, under what conditions you don't have to go for a blockchain becomes very clear or the other. And so the technological challenges, as I mentioned, consensus protocols. There are varieties of consensus protocols that have come into the picture. And now Ethereum, which was working on POW, is now switched to POS completely. And the scalability and performance and fairness requirements and post-quantum requirements. Fairness requirements, whenever you want to change scalability and performance, fairness suffers. And so this is a key factor. You don't know what happens. For example, if you compare with the Bitcoin transactions and Ethereum transactions, the number of forks that are created in Ethereum, at least when it was using the POW, was enormously large. So now you don't know what the things are, kind of a thing or the other. There are many other things. This is another structure, the same thing coming into the picture. Now let us go into the scope of applications. And so now here, this is the classic one, so I will not repeat it. And now is a trust management framework. Trust is a subjective, non-transitive notion. That means if A believes B and B believes C, A need not have to believe C. That is one like the web kind of a thing. If I believe one and if I believe another one, it does not have to do that. Blockchain, you have distributed, transparent, continuous auditability. In the first generation smart contracts are all financial transfers. And then you have a varieties of applications. I don't think there is anything that is left out. But the thing what you have to see is that the supply chain is one of the things which have adopted the blockchain to an enormous extent or the other, including the private consortium or the other. Finance, trading. For example, I will look at a DAO or a decentralized autonomous organization, online lotteries, smart contract-based pension funds, and so on and so forth. Let me just give what would it mean by a decentralized autonomous organization? Organization running on a fully democratic way. So now it's a group of people who have common interest. They want to generate money for the shareholders, need to follow the rules of land where it is incorporated. You can even take the example of the recent bank of the SVB in California. That's a different issue altogether. Group of shareholders who represent ownership in percentage of the capital. Shares can be transferred or transfer of ownership. Board of directors with a CEO to run on day-to-day affairs, bylaws, memorandum of articles, article of association, and DAO is the digital version of this. So now here, executed by thousands of people through consensus, DAO runs on a blockchain, Ethereum blockchain, let us say written in a language called Solidity. And each action or vote is represented through a transaction on a blockchain. Members are represented by addresses. Addresses can be owned by people, robots, IoTs, or even another DAO. Functions automatically without any central control. Each member is given a token representing his shares in the DAO, can be used to vote in the DAO for any of the actions to be taken. Token is nothing but another contract running on the blockchain. So full democracy, voting could be delegated, that is a proxy. Can raise funds through crowdfunding, issuing tokens and shares to those to pay to DAO. Paying and issuing can be taken in real time, like many which were taking more than 60 days in a physical organization. So it could be, now you have saved lot of time or the other. So now I will not go into, there have been problems which I will address. Now I will come back to the classic input tax credit in the GST. I don't know how much people are happy with the GST implementation or whatever it is. For example, a simple understanding of the input credit, you have a tax credit, a tax paid on some components, let us say ABC, and now the output tax with, let us say he has paid 450, he can take a rebate of what has been paid on the components and things like that. Now the question is that how do you actually model it as a smart contract? So now one of the simplest thing what you could do in this simplest case, you see the arrows have become rigid. There are no multiple arrows. That means there are no multiple writers. And now here, if you come for the simple case, there is something like the ERC20 token, which itself has a problem when you have multiple writers, and that can be done without problem. So now I have shown in another paper, which I will not go, when you have multiple writers or concurrent cases, the ERC20 is not correct, is incorrect. How to overcome that? I can find a procedure to say under what conditions the constraint have to be satisfied so that it can still go, that means the performance can go, etc. kind of a thing. Similar thing we are trying to show that input tax credit, even if it is multiple, what do you mean? That means this could be shared by many people. That means that somebody can take 20 rupees out of that and 80 rupees somebody can take over it, and that becomes concurrent transactions. How many persons are doing it, it becomes concurrent, and that is something that has to be implemented in a nice manner. I'm not sure what is the way that one is happening in the current context or the other. And this is where the smart contract will play a role, because it guarantees that there is no possibility of cheating unless this tax credit has been paid, invoice has been paid, you will not get that rebate kind of a thing. Now, based on some paper, you may get a rebate, and so there may be a disturbance in the ledger kind of a thing or the other. And so you have various other applications like remittances, the supply chain, agricultural supply chain, and traceability, and secure contract negotiation, etc., including an auction kind of a thing or the other. And so this is one of the major things, as you know your customer. So for example, if you see identity becomes an important thing, one of the blockchain is the sovereign blockchain, which enforces the identity kind of a thing. Now the question is that using that, would it be possible for you to have only one KYC rather than multiple KYCs times kind of a thing or the other, and then personal data management and notary services, healthcare, land management, etc., kind of a thing. Of course, in CBDC, you see as an alternative, the technological guarantees like double spending avoidance, traceability, have prompting, and also CBDC has something of a different nature because that affects the economy, and how, for example, Cambodia has implemented a CBDC in US dollars, not in their currency. The question is that then nobody may be using the local currency. And so now Indian rupee, if we have a CBDC, which is now restricted to only a finite number of banks, if it is distributed across the whole country, maybe if our user interface is very good, maybe rupee can become win over many other currencies to say that this is much easier to do and share, and money laundering can be overcome, and also privacy can be maintained, and all these aspects will be the challenge from the technological perspective of implementing this. Once you have a CBDC, what is one of the reasons for CBDC is it has to go to everyone in an inclusive way. For example, even in US, 20 million people don't have bank accounts either for wantonly, or they don't want to, or they don't believe it, or whatever that one is, kind of a thing or the other. So that is one of the things, inclusivity as well as trying to overcome the money laundering issue. So you have to put in a hierarchical manner both privacy as well as money laundering, without which it will not be accepted. It's very important. A currency has to be accepted by the society. It is not the technology people who would accept it. It's the society that has to accept it. And now it has to be made in such a way, when they want privacy, they have, and when the government wants money laundering, it is there. And what is the level at which it has to be done? It has to be done in a very nice manner, kind of a thing or the other. And so this is another important point which I will not go into, like water markets can also be effectively put on a blockchain to say that how water can be traded. For example, this happens in California from one area to another, how the arid areas can conserve and get water and money, like that kind of a thing or the other, and varieties of things or the other. These are something which I will, this one. So scope. So now here, the important thing which I think is smart contracts, correctness is a very important aspect. As I mentioned, like the Oracle. Programming languages, there have been many, Solidity, Go, DAML, and so on and so forth. Well-known attacks from exploitation of language features. The one example, what I gave of the DAO, was $50 million was taken away by somebody announced there is a vulnerability, and then they got over it. And existing approaches for this, these are all based on static analysis, transformation, etc. kind of a thing. Even people use machine learning. So machine learning is a post facto. That means that after one has lost the money, you do that and say why we have lost it. It has no value, but by then you have already lost the money, kind of a thing. And so the only thing is the runtime framework, glimpse of solutions and lifting solutions to declarative notions. That means how you can ask the programmer to give little bit of that kind of a thing. And so now here if you look, and this is something important what one has to understand, smart contracts on shared memory, because blockchain is a shared memory across many processes. This becomes the challenge of distributed programming. Even today, distributed programming correctness is a real challenge. And now here you say how they are the same. Accounts using smart contracts in a blockchain are like threads using concurrent objects in a shared memory. Contract state is nothing but object state. Call or send is nothing but context switching. Reentrancy, which I will not go, uncooperative multitasking, invariance are something like an atomicity, and non-determinism is something like a data races. People who use Java, data races common to them, but that's a different issue altogether, kind of a thing or the other. So now how did we solve it? So one of the major problems in the concurrency is everything is done if you do it in a disciplined way by mutual exclusion. Only one person can act at a time. So now how do we maximize the parallelism? We did it from a programming language perspective long back, and using the same thing, what we have tried to do is trying to show that if you use different declarative classes like non-inherent access pattern, parallel constraints, and so on and so forth, you would be in a position to derive what is called a solidity plus plus, but solidity plus plus can itself be transferred to solidity, and you are going to actually, this is something declarations plus solidity program is nothing but the solidity plus program, and then you have a processor, and you say that it's a secure solidity program, and this is what it would look like. Or the advantages would be simple declarations are intuitive and can be handled by a general programmer in line with the understanding. Runtime checks are added to the program as per declarations. These are all automatic, allows programmer to debug at the source level rather than at a EVM level. So this is something, if you ask people to debug at an assembly level for which you don't know what the source looks like, it becomes extremely difficult. And then using this kind of a thing, integrated development for solidity, characterization of decidable fragments, and so on and so forth. And so now another question comes. There are many languages. For example, if you look at Ripple, there is no smart contract. They have a blockchain platform. So now how do we enrich to introduce different smart contracts? It is done through what is called the hooks. Now if you want to add some programs at those points to enrich the smart contract, now under what conditions the guard should be satisfied is something that needs to be worked out. And now we can also use something what we called as a proof carrying code, which is used for a sequential context or the other. So history, I think I will skip the history because it goes to Roman history, keeping the ledger. So now let us go to traditional contracts versus the small contracts. I have, I think, 5 more minutes, and that should be good enough to say that. Smart contracts, courts, lawyers, and consumers. An automatically self-performing smart contract can truly exist in a pure virtual world, but becomes more complex when connecting to the real world, necessitating interfaces between the software and the reality. Interface starts with oracles providing real-world parameters for coded self-performance and extending to other links to ensure contract content validation, contract legality, lawfulness of contract purpose, and measurement of contract. Complexity has 2 significant aspects. Now question you can ask is it more or less work for lawyers and judges? That is something you have to ask. Enhanced reliance on burden of proof, enhanced advantage to party expertise, and an enhanced significance for party asymmetry. So in the electronic platforms and the smart contracts, suitability of the electronic platforms as contract substitutes, and hope for the expanded use of platforms if they are secure, resilient, and adaptable, capable of continually and swiftly accommodating legal requirements. If you don't have, the electronic platform will not be accepted by the society. So now let us see what are the conflict areas between smart contracts and the traditional contracts. Flexible, enforceable legal contracts versus firm, self-enforcing smart contracts. Traditional contract is flexible, while smart contracts are rigid because they are immutable. Once the smart contract terms have been programmed into the code and executed onto blockchain, there is no longer a need of reliance on the willingness of the various parties to perform. Code is law. And so smart contracts are performance based and ensure a greater likelihood of performance than conventional contracts. And so now the second one is different aims of legal contracts and smart contracts. Smart contracts does not challenge the traditional rules of contract. However, their self-enforcing nature does, because the traditional enforcers, courts and arbitral tribunals, might be helpless in providing an ex post solution because it is rigid. This is the essential conflict between the immutability of the smart contracts. Smart contracts have been called the first real disruptive innovation in the legal profession, and it is said that the technology will eliminate or at least drastically reduce the need for lawyers, paralegals, judges, or arbitrators. So now here, the computer code versus natural language. While programming language may in fact remove linguistic ambiguity, it will remain helpless in relation to changes of circumstances, lacuna, and questions of equity or good faith. This is something, good faith is a very important aspect in the contract law. Consumer protection law and the smart contracts. Another element of conflict between smart contracts and traditional contract law is the protection of weaker parties, an idea that traditional contract law contains and which became utmost importance with the rise of consumer protection. Another highly problematic area is the application of the unfair terms directive to smart contracts, an area which is important for the determination of the content of a formatted contract. That means here, unfair terms directive clearly states that the fact that certain terms have been individually negotiated shall not exclude the application of the unfair terms directive. This becomes a challenging thing in the context of grievances and etc. Law of excuse for non-performance. The law of excuses for non-performance is the result of a long and complicated history. The right of the creditor to performance is, however, not absolute. Every legal system recognizes that performance may be frustrated in various ways without thereby making the debtor liable for breach of contract. And so general analysis of the doctrine of excuses for non-performance based primarily on the draft common framework as a set of model rules drafted by the European legal fraternity on the basis of extensive comparative research amongst the legal systems of most European countries. And so now here, one thing, let me just spend 2 minutes in the various definitions. I will not go into. There are various things you could see that, and is implemented in software and by a mixture of both. And now you can see which are automatically executed by a machine, and now again do not need artificial intelligence to that. So this is something I want to highlight, are not merely digital contracts, nor they are entailing AI, and that a smart contract doesn't think like a lawyer does. Instead, smart contracts enforce the lines of computer code which they have been programmed for. So smart contracts do not need AI to work. A smart contract should thus be perceived as an automated mechanism which performs its defined functions as certain preconditions are met. In fact, even in Szabo, he never said about AI, which is the start for the smart contracts. Note that smart contracts are based on logic of cause and action that are predetermined by the smart contracts author, and so that's how it becomes a very important thing. And now if you look at a summary, you can see consisting of formalism, fixed and hard rules, certainty and predictability, and what is the context, blend of fixed rules, standards or open textured rules, or ensure a degree of fairness or justice. In fact, fairness and justice, even in ML and AI, is one of the main things comes into the picture. If you look, what is the ethics in AI comes into the picture or the other. For example, if you have a loan, and now in the data you don't have people who are of the other one class of society, they will be completely omitted because that is not part of the data. It's a chicken and egg problem comes into the picture or the other. So to conclude, so in the era of digital transformation, the challenge is to transform contracts to smart contracts. What can be transformed, what cannot be done, how much decentralization can be done, how much decentralization cannot be done, and how the middleman can be avoided, and then automation of payment systems, including a DCBDC kind of a thing. Blockchains and smart contracts, you have the complete provenance and traceability possible on the smart contract. Again, one has to see that the power of smart contract languages has to be limited, and you have to be sure that the smart contract languages are executing as intended. If you do not do that, you don't know when the error will arise and how much you would lose. It becomes an extremely difficult thing. And classes of DLTs with families of smart contract languages is one of the things what one has to think about. And of course, it's an exciting interdisciplinary area of technology, economics, law, and society. With that, I will stop here and thank you for a patient listening. And I'm open for any questions or comments.
Can I have a question here? Okay.
So technically, in my view, AI and smart contract have no role. Okay? So now technically you can also call, in the current terminology of the compiler, also is an artificial intelligence system, right? Because it correctly executes it. So AI has no technical role. AI has a role only for providing proper interfaces to the persons, and that's where it's very important. Whereas otherwise, you don't have to have a blockchain. So the blockchain, if you want to have a blockchain, you have to answer those questions to say that, are there going to be multiple writers? For example, in the context of a simple GST example, I said, if there is only one person who is going to take this input tax credit, there is no need of a blockchain. Database will do. Whereas now, the same thing can be used by multiple units of the owner concurrently, then you need a blockchain, because that cannot be handled very easily in the context of a pure database kind of a thing. But the challenge is, like as I already mentioned, all contracts cannot be transformed into an executable smart contracts, but they can be done provided you introduce many oracles. Some of the oracles may be even human beings.
There is a question here.
Yeah, hello, sir. Thank you so much. Vineet Sachdev. I come from a non-banking finance company. Like you mentioned, there can be really many frustrations which can occur in a ordinary conventional day-to-day contract getting executed. Is there any, looking at the present legal scenario, and there can be delays, there can be frustrations in any sort of debtor creditor or any sort of trade contract, is there any flexibility which can be built within your smart contract to allow that?
So you see, one of these classic cases is the application of blockchain for supply chain. So now, for example, people have tried, particularly IBM, even perishable food, how it can be transferred, because if the delay happens in the customer phase, either for payment or something like that, you lose a lot of money or the other. And that it can be triggered automatically to say it has to be finished, and it can be done quite quickly or the other. In supply chain is a good example wherein you can also enforce so-called, what I mentioned earlier, some notion of an AI, what is the probability this has to be triggered early, kind of a thing or the other kind of thing. I don't know whether it answered.
No, I understand what you just said, sir. I'm thinking in several contracts, at times, if we are extremely rigid, because there's a cause and effect and rules, it can lead to disputes which, which will keep occurring very, very frequently. Whereas in conventional contracts, you give it a little breather, and you are able to still maintain the validity of the contract, complete the transaction, maybe with a little delay, maybe with a little adjustment. Can a smart contract also accommodate that?
Yeah. So let me first tell, first is how much the contract is to be transformed into the smart contract. So in the question of the smart contract, it can take into, now something you have found, there is something wrong, because the rules have changed from the government. It has to be this one. So now again it goes through the consensus. I can generate a new contract to say that the old contract is now defunct. From this timestamp onwards, it is the new contract that comes into the picture, and the old data is no longer applicable as far as this data is concerned, kind of a thing. That is the way the code can be done, kind of a thing or the other. For example, if you see in the Bitcoin, you always say it is a trust which is obtained from untrusted people, or thieves will lead to a very trusted agent or the other. But the question, if you look at it, where is the trust? Trust cannot be, can only be relocated, cannot be created. Where is the trust now in the Bitcoin? His question is that one is the underlying crypto mathematics. So now if the crypto mathematics is shown to be false, then the whole thing collapses. Okay? And then it is not ending there, that is the theory. And now that has been transformed into a programming language, and if the transformation of the programming language is not actually completely equivalent, then there can be a problem or the other. And so now, and then the hardware. Now that lots of people use blockchain, there is no need of a specified, only a small persons of some particular company manufactures, you can use off-the-shelf machines, so that the trust perhaps is much more because lots of machines are being used. The trust is on hardware, mathematics, and the programming language. And so these are the things, trust have been relocated, and that's what one has to see that there. Like that is where in the quantum cryptography comes into the picture. Now the question comes into the picture, what happens? That is one aspect that one has to look into. Another aspect what one has to look into is that assuming I have a quantum cryptography, is it possible all my characteristic of the blockchain by the performance and this one, will they still satisfy when I construct many of these things? So this becomes an important thing to say, what would be a blockchain in a post-quantum cryptography?
So just to clarify, you mentioned when there's so in existing smart contract, if one of the parties wants to change something, they can propose a fresh consensus and a fresh contract will be created therein.
And this has to be consensus.
Consensus
all
driven.
the stakeholders have to agree.
Yeah.
If they don't agree, it won't go there.
Or it could be a weighted consensus
Yes,
as well.
yes. And like that's where the consensus becomes, so a new can add a new smart contract.
All right, sir. Thank you.
Excuse me, sir. The smart contract is definitely fixed in hard rules, but it is.
Can I, can you repeat?
Yes, sir. Here, sir.
Yeah.
It is definitely very rigid, but it is not flexible. So it definitely rules out corruption. But sometimes what happens in contracts, some clauses we do minor deviations, so we accept it. But in smart contracts, those will not be accepted, and ultimately contract fails. So
No, that is what in the last point what I made, the difference between the classic traditional contract and the smart contract. If there is something like a performance, the performance got reduced because he had a COVID. There is no way that the smart contract knows. It will just say his performance was bad. So like that, and then you can say what is the conditions in which, like earthquake has happened. So there is no way to record that kind of a thing. All this has to be done in a separate manner, and so that is something what you have to gear it into the smart contract through the oracle, which one would say if this condition happens, then what is the way things have to be dealt with, kind of a thing. By unused kind of an oracle can be used, brought in at a later point, before itself one can put it in.
So, no, actually, for this our vendors are to be educated because they have to be very strict according to the contracts. And but sometimes we adjust, because for small points you don't reject the tenders, and whereas smart contract will reject those things. And so it may not be suitable for Indian conditions. That is what I am saying. Because our vendors and our people are not that rigid.
The large spectrum, how they are being used. For example, if you say this much money has to go to the agricultural people, so all the farmers should get this much money. Now can I record? and the banks have to give this much loan to the banks. Can I now record it on a blockchain? Can it become transparent? And all these things at a higher level, you would say that how much money the state government has returned to the bank, what was given by the bank. Now if you look at it, whole the economy of them will become completely transparent.
Sir, I think it will be, for Indian condition, it will be a combination of smart contract and traditional contract that would work.
Yeah, you know, technically, as I already mentioned, one of the oracles could be a human. Now, like what I said in one of the simplest example of a will, I had said he has graduated. So that is something which is found. Similarly, you can say, is there an oracle of a higher order, or let us say some vigilance officer who now gives an input, then you can do something else kind of thing.
Okay, thank you, sir.
Okay, we have time up for the question for the first lecture. Thanks a lot, Professor Shyamsundar.
Thank you.
Thank you so much, sir. Now I would request Dr. Madhuranjan Kumar to come over the stage and hand over the memento to Professor Shyamsundar.